Hello everyone, today we will solve another equilibrium problem. The problem here states in figure 37, which is this one, if the horizontal and vertical components of the reaction at C are C horizontal component is 500 pound and C vertical component, which is y axis, is equal 866 pound. We have to find the W. So let's draw the free body diagram. Here FBD, which is the short form of free body diagram, let's draw it. If we draw it this way, the W is pulling the whole system downward, and the BC member, and the here force is C, so it should pull it this way, and the AB, which is A, is this way. Okay, here we have the angle, which is 60 degree, and in this way it's also 60 degree from the figure. Okay, now if we write it down, we get AB this way and BC this way, or CB, which way we call it, it doesn't matter. Okay, now here we get C are CX and CY, so we have this force divided into two components. So we can show it in other way, like this one, that we are finding C, but it is divided into two parts. Here it is 60 degree, and we get at y axis, or CY this way and CX this way. So we have to use these two components to find the C. So we will use the resultant theory, which is R square is equal F1 square plus F2 square plus 2 F1 into F2 cos alpha or theta, which way we call it, doesn't matter. So we will get it here from this. We can write it like this. Here F1 we can take it as the X component, which is 500 pound. Okay, and then F2, which is the Y component, 866 pound. Then here R is equal to C, which we have to find out first. So let's write it down with the values. 500 square plus 866 square, and we will omit this part because here alpha is equal 90 degree, because we have two axes in this reaction, because x axis and y axis have a difference in 90 degree, and we know that cos 90 degree is equal 0, so we can omit that part. Then we can write it down like this: 500 square plus 866 square. Okay, then if we solve it, we get 500 square plus 866 square, and if we square root it, we get roughly 1000 pound. Okay, so here we can write it as, in free body, this is 1000 pound, and due to symmetry AB is also 1000 pound, because here both makes an angle 60 degree here and here also, so these both angles are mirrored, so the amount of force applied here will be also the same. Then we can apply the Lamis theorem. Applying Lamis theorem, we get W divided by sine alpha. Let's not confuse it with this one, is equal, let's take only one component, or we can write the full formula here. Sine beta is equal F2 sine gamma. Here in the free body diagram we can show it this way. W is pulling downward, so the alpha angle will be this one. And for AB and W, this will be okay, so for the AB this will be the beta, and for BC this will be the gamma. So we can choose either because both are same. So let's take only one and write it down here. W by sine alpha, and if we put the value also, then let's find out. Here it's a straight line, so this is 180 degree, and if we subtract 60 degree and this 60 degree, so total we are subtracting 120 degree, so we get 60 degree. And then for F1 we can take 1000 pound and use sine beta, and which is 90 degree plus 60 degree, and if we add up then we get 90 and 60 is equal 150 degree, and if we solve it then we will get the value of W. By writing it this way, we get 1000 into sine 60 degree divided by sine 150 degree, and if we calculate it we get sine 60 divided sine 150. So the value of W is 1732.05 pound. So this will be the answer. Thanks for watching.